Welcome to the Mind Cable Repair tutorial presented by Splice One. Today we will be demonstrating splicing techniques on a number 2-3 GGC cable. Refer to the supplied instruction sheet before attempting any cable repair and make sure that the proper cable is disconnected, locked out, and suitably tagged. If more than one phase is damaged, completely cut out the damaged section of cable, exposing two clean ends. Remove only enough cable jacket necessary to properly stagger connections and properly complete the splice. This amount will vary based on cable size. In this example, we have determined the amount of jacket needed for removal and marked with PVC tape on each end. After making a circle cut at the marks, we carefully remove the jacket by making a longitudinal cut towards the end of the cable, being careful not to damage the wiring bundle beneath. In order to properly stagger our connections in this demonstration, we have lined up each cable end with the leads parallel to each other and marked at these parallel points. Cut each lead at these marks. Slide the two cable ends together to ensure proper tension before removal of insulation in preparation to connect the leads. In order to determine the proper amount of insulation to remove, in this example, we use the indentation in the center of our copper butt connectors as a guide and mark each lead for removal of insulation. We then use a score cut at these marks and to the end of the leads and remove the insulation, being careful not to damage the inner wire strangle. We also remove the factory separating tape beneath the insulation. Next, make proper connections and insulate phase leads, grounds, and ground checks when present. In this instance, we connect the phase leads using our copper butt connectors by inserting the opposing ends of the lead inside the connector and crimping on each side. Insulate phase leads using optional components listed on the instruction sheet. All tape should be applied half-lapped, tightly stretched, and tied back into the original insulation. In this example, we begin by covering the connection with high-temperature fiberglass cloth tape. This step will help to dissipate heat as well as add mechanical strength to the connection. Unlike the remaining tapes, this layer only needs to cover the connector. Next, we apply PVC tape over the fiberglass cloth tape. This step is to extend past the fiberglass cloth tape and be tied back into the original insulation. Following the PVC tape, we apply linerless high-voltage rubber splicing tape. This step is to extend past the PVC tape and be tied back into the original insulation. After applying the linerless high-voltage rubber splicing tape, we again apply PVC tape. This step is to not only help insulate the connection, but also protect the soft rubber from abrasion, and should extend past the rubber tape and tie back into the original insulation. Repeat the previous steps for connecting and insulating on the remaining leads. Carefully remove the factory separator tape from the grounds if present. Place the grounds back into their original valleys to prepare to properly connect. In this example, we are using our copper butt connectors for the grounds as we did with the phase leads, so it will be trimmed to just butt together. In the same fashion, slide both ends of the ground into the copper butt connector and crimp on each end. As with the grounds, place the ground check back into its original valley to prepare to properly connect. We will also be using a copper butt connector for the ground check, so it will be trimmed to just butt together. As with the phase leads, we use the indentation on the copper butt connector to determine how much of the ground check jacket to remove. In this example, we mark at these points and make score cuts at these marks. We also flatten the jacket with hand pliers in order to loosen the wire stranding from the jacket. We then make a score cut towards the end of the wire and carefully remove the jacket, being careful not to damage the inner wire stranding. After carefully removing the jacket, reconnect the ground check in the same manner as the phase leads and grounds by sliding each end of the wire into the butt connector and crimping on both ends. Insulate the ground check in the same progression as the phase leads. Begin with fiberglass cloth tape, then PVC tape, followed by linerless rubber splicing tape and PVC tape. Each of these layers should be half-lapped, tightly stretched, and extend past the previous layer and tie back into the original jacket. In preparation to rebuild the cable jacket, thoroughly abrade the original jacket with provided abrasive strips. Thoroughly clean the original jacket with the provided solvent wipes. Wrap the entire spliced area with high-temperature fiberglass cloth tape. This layer will create a sheath for the cable core and help dissipate heat from the jacket vulcanization process. This layer should only cover the spliced area and be applied half-lapped and tightly stretched. Wrap the entire spliced area with vulcanizable jacketing tape. This layer should be built up to at least the original diameter of the cable, as well as the inside diameter of the vulcanizing press mold. Extend this layer onto the original cable jacket at least 2 inches past each end of the spliced area. Place the splice into the vulcanizing press mold and follow vulcanizing press manufacturer's instructions for vulcanization. In this demonstration, we sprayed the vulcanizing mold as well as the splice with release agent and place in the vulcanizing press set to 300 degrees for 45 minutes. Once the splice has been in the vulcanizing press for specified time and temperature, allow jacket to cool. After the splice has cooled, cut the ends of the splice to a taper. After tapering both ends, smooth any rough spots on the splice and the tapered ends. After applying MSHA approval number onto jacket with Splice 1 stamping tool, the splice is complete and ready for service.